Algebra 1, Ratios and Solving Proportions. In this part of the concept, we're going to focus on proportions. So let's get down some vocabulary definitions and formulas. Now remember, you may need to pause the video so you can copy down some things while you're taking notes. So first of all, a proportion is an equation where one ratio or rate is set equal to each other because they are equal. And I have an example down below there under the definition of cross multiply. So this right here, the first part of this example, that's your proportion. Now one method to solve a proportion is to do what we call cross multiply. So if two ratios are set equal to each other, this method can be used. And this image shows you how you cross multiply. The name kind of explains it. So you take the numerator of your ratio on the left and you multiply it by the denominator on the right. And then notice it goes on one side of the equal sign. So we keep our equal sign lined up. So that product goes on one side, and then you take the denominator of the ratio on the left and multiply it by the numerator of the ratio on the right. And that goes on the other side. And so that's just a little shortcut method for solving for x. And then you just continue, and whatever you would need to do to get x by itself, you would solve that equation. But this is a method to solve proportions, cross multiplying. And you'll find that really useful, and you'll use that the rest of your math career. Our first problems will be real life situations. So let's just read it and then we'll set up our ratios. A metal bar 10 feet long weighs 128 pounds. What is the weight of a similar bar that is 2.5 feet long? So remember that a rate is it's a comparison by division of one unit to another. So we've got 10 feet compared to 128 pounds. I'm going to include my units because with our our rate that's equal, we need to line up our units. So we need to start with feet, and we were given the length of the new bar, but we don't know what the weight is. That's our unknown. So we're just going to let a variable stand in for that, and I'll just use x. I could have used w. And then what we're going to do is cross multiply. Now when I do the math, I'm going to drop my units. So 10 times x is simply 10x. And then 128 times 2.5 is 320. And then I know to get x by itself, I need to just divide both sides by 10. And at the very end, I'm going to have my units show back up. So I'm solving for weight. So 32 pounds. Now let's look at number 2. So the tax on a property with an assessed value of $70,000 is $1,100 or $1,100. What's the assessed value of a property if the tax is $1,400? So notice we're comparing one unit to another. So we've got, well, it's all in dollars, but property compared to tax. So $70,000 in property, $1,100 in tax. So what we want is property compared to tax on the other side. So we know the tax, so I'm going to place it across from the tax on our left rate, and then we don't know the assessed value. So sometimes it will change where you place your variable, just depending on what you're looking for. So 70,000 times 1,400 is 98 million. And then 1,100 times x is just that. And then we just need to solve for x, so we can just divide both sides by 1,100. So 8, 9. Now I'm told to round to the nearest dollar, so that would be $191. and then I'm going to label this as money, and then I'm just going to look and make sure my answer is reasonable. It is. So my original property was $70,000 with the tax of $1,100. The tax in the new situation is increased a little, so that means the value on the property would also increase, and my answer is a little bit bigger. So that is a good, reasonable answer. Let's look at number 3. When 2,000 pounds of paper are recycled or reused, 17 trees are saved. How many trees are saved if 5,000 pounds of paper is recycled? So we'll start with that one. Notice that we have pounds, 2,000 pounds for every 17 trees. I'm going to go ahead and put those labels in, just because then it helps us write in the numbers with our ratio on the other side. How many trees are saved if 5,000? So we'll go 5,000 pounds compared to X number of trees. We don't know. So now we'll cross multiply. We'll just focus on the numbers and variables for right now. 17 times 5,000 is 85,000. And then when I divide both sides by 2,000, 42.5 trees. I'm going to go ahead and list it like that. You may think, well, that's not exactly realistic to save half a tree, but now the second part is how many trees are saved if 10,000 pounds of paper is recycled. So we can just set this up the same way. Weight compared to trees equals weight compared to trees, which is our unknown. And then we can solve it. So 2,000x equals 170,000. You can see that the process to solve is the same each time. 34 trees. Now you may have just answered that using mental math, because if you remembered our original, 2,000 pounds saves 17 trees, and then 10,000 nope, sorry, not 34 trees. If I divide by 2,000, I'll actually get 85 trees. Number 4 is a really typical conversion problem. The scale of a map is 1 centimeter to 80 kilometers. What is the actual distance between two towns that are 3 centimeters apart on a map? Maps are drawn to scale so that the distance on the actual physical map can help you know the actual distance in real life. So we can set up 1 centimeter to 80 kilometers. And then we're going to have the same centimeters compared to kilometers. So we know our centimeters here. We don't know our kilometers. So if we cross multiply, 1 times x is x. 80 times 3 is 240. And that's kilometers. Now the last 3 problems that we're going to do are not in a real life context. They're just isolated math problems. The proportions are already set up for us, so all we need to do is cross multiply. But there's a few things that come up in how to cross multiply. For example, look at number 4. You've got x over 2 equals x plus 2 over 4. Variables on both sides. But our method's still the same. This numerator times that denominator. So x times 4 is 4x. And then 2 times all of x plus 2. So you want to put that expression in a parentheses. And then you're going to distribute the 2 so that you multiply all of that expression by 2. Then you'll just look at your problem and you need to figure out how to get x by itself. So you can move your 2 x's over and then divide by 2. So each time the actual solve of the equation will be a little different, but the beginning method is the same, cross multiply. When you have one ratio set equal to another. On number 6, you've got your denominator variable in the denominator. And so we had that in a couple examples earlier. So we'll just start, and we can cross multiply. So 22x, and then 4 times 11. Divide both sides by 22. So x equals 2. And then our last, number 7. Now we've got our variable in the upper left hand position. But again, the method's the same. So numerator times denominator, and that goes on one side of the equal sign. 7 times 3 is 21. Divide by 5. And we can just leave that in fraction form. 21/5.